Hi, good to see you again. Welcome to Block 5, Addition and Subtraction of Fractions, Lesson 5. I'll share my screen. So, in your previous lesson, you learned how to add and subtract fractions that had the same denominator. In today's lesson, you're going to learn how to add and subtract fractions from integers. So I repeat, you're going to learn how to add and subtract fractions from integers, meaning you're going to have a whole number and you're either going to add fractions to those whole numbers or subtract fractions from those whole numbers. So it's a very important concept you need to understand, which helps you solidify your understanding of fractions, which is really one of the topics that students find challenging. And then you will also learn how to express the answer as a single fraction. Of course, you would have learned that already. So we'll put all these together in this lesson to enhance your understanding of fractions. But before we progress, remember to like the video, share the video with those you think can benefit from it, subscribe to the channel, and click on the notification bell so that when new videos are released, you'll be notified. By doing so, you help us grow our mission to create a platform where children, regardless of their financial circumstance, can have access to high quality maths education in its fullness, regardless of their financial situation. All they need is internet access. So be charitable, provide internet access to a child you think is lacking in maths education, and help them learn. Thank you. Before we start, I would like you to answer the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So that one, you were asked to work out the missing fraction in each calculation. Well, we have a whole as the answer. So we know that the whole, the denominator being seventh, should tell us that to get a whole, it has to be 7/7. So we'll be using this concept about letting the denominator determine what we need to do with the fractions. So in this case, if we know that the whole is equivalent to 7/7, it means that number that is missing should be 5, because 2 plus 5 is 7. Here, we have two wholes. So remember, the concept is to allow the denominator determine what value the whole is going to take. So in this case, our denominator is 11. Remember what we learned, that the denominator determines the number of parts you are sharing things into. So it means a whole in this context is 11/11. But now we have two wholes. So it means the two wholes should be equivalent to 22/11. Now, if it is 22/11, the number that should be missing there should be 19, because 19 add 3 is 22/11. Next, we're asked to convert the mixed number to an improper fraction. By now, you should know that the concept is to allow the denominator tell us the number of parts in which we're dividing things into. So in this case, a whole will be 5/5, so 5/5. But here we have 7 wholes. So the number that should be in the numerator must be 7 5/5, which is 35, plus the 2, which is 37/5. Well, that is one way of understanding it. But remember the quick method I told you to do. You simply do 5 times 7, which is 35, plus 2 in the numerator. That gives you 37/5. But my earlier explanation is to help you understand exactly why we do this. And it's the same for question 3. Here we have 72/5. Now we're going to be thinking that, okay, we have 5 in the denominator, so 5/5 is a whole. So we're thinking how many 5/5, or another way of thinking about it, if we divide 72 by 5, how many fives can we get from 72? Of course, it is 14, because 5 times 14 is 70. We have a remainder of 2, so that should be 14 divide 14 whole number 2/5. Let's do some new learning for this lesson. Here, she says 5/8 plus 3/8 is equal to 8/16. Have a think, what mistake has she made? You may refer to what you learned in our previous lesson about adding fractions with the same denominators. Well, if we model this question to explain how she has made a mistake, here is what 5/5 looks like. 5/8 looks like. So 5/8 means you have 8 equal parts, and then 5 of which are shaded. 3/8 means you have 8 equal parts, of which 3 parts are shaded. But if we represent 8/16, can you see that 8/16 in terms of size is actually smaller than 5/8? Of course, you can see that that should be wrong. So our answer, if we were to take these 3 parts and add it to that, which is what we're doing, we will see that we have a whole, because 5 plus 3, remember what we learned in our previous lesson, if the denominators are the same, you simply concentrate on doing what you need to do, either adding or subtracting the numerator. So in this case, we'll have 8/8, which is a whole. So you can see the whole diagram or block is shaded. The bar model is shaded. What about this one? If we want to subtract 1/7 from a whole, how do we model this? Have a think. Well, remember what we said, that if we have a whole, this is a whole bar model, but what the integers or the whole, what value it takes or the number of parts it takes is determined by what you are doing with it. So in this case, we're trying to subtract 1/7 from it. So it will make sense to convert this whole to 7 parts. Now, 1/7 means you want to take 1 part from that 7 equal parts, because it means a whole subtract 1/7. And that means 7/7 subtract 1/7. So our whole takes 7 equal parts because we're trying to subtract something that has 7 in the denominator. So in this case, it has to be 7/7. That gives us 6/7 as our answer. Let's apply the same concept here. If we use the same concept real quick, we can see that the denominator is 7. So our whole has to be in 7 parts so that we can work with it with the 1/7, which has 7 in the denominator. Now, in that case, this means having a whole plus 1/7. Now, a whole plus 1/7, you can clearly see that that will be 1/1/7. And then you can see, if we want to write it as an improper fraction, we can simply say 7 times 1 is 7, plus 1 is 8, or 8/7. Using this, you can also use the bar model to see why it is 8/7. Remember, the denominator tells us the number of parts tells us how many parts the whole has been split into, and the numerator tells us the number of parts we're interested in or that has been shaded. So you can see why it should look like this, which means it is 8/7. It's now time for you to practice. Pause the video and answer questions 1, 2, 3 in 3 minutes. Assuming you've paused the video and you've answered questions 1 to 3, here are the answers. Let's discuss them. For the first one, you will ask, what is the same about the answers to the three calculations? They are all equal to 1, and I am sure you've noticed that. Here, you're asked to use a bar model to explain why 2/5 plus 2/5 plus as why 3/5 plus 2/5 is equal to 1. Of course, you can see the bar model here. If you have a whole, remember the denominator tells you the number of parts you're going to split your whole into. Now, 3/5 means you need to shade 3 out of those 5 parts, and then you're adding 2/5, you shade another two parts, which takes the whole 5 parts. Here, you're asked to use the bar model to work out the calculations. This simply means a whole. You can see that because we have this fraction as being 1/3, we're trying to subtract 1/3 from a whole. It means the whole has to be split into 3 equal parts so that we can do our calculation. And then subtracting 1/3 means to get rid of one part of the 3 parts, or to shade one part of the 3 parts, which means you'll be left with 2/3. And that's the same we have done here. You can see it's the same method we have used here. So if we were to rewrite this, it will be like saying, thinking about what we've learned so far, the whole will take the number of parts determined by the denominator of what you're trying to do with it. So in this case, we're trying to subtract 1/3 from it. So this whole is actually worth 3/3, because 3/3 is equal to 1. Here is the same thing, but here, this whole is now 7/7. Why? Because we're trying to subtract 3/7 from it. So the denominator determines the number of parts in which our integer should take. Pause the video and answer question 4 in 3 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Let's discuss them. So using the same idea, we see that we have a fifth here. So this whole has to be 5/5. Here, I'll just discuss them. I'll go along. This whole will be 5/5. So you simply do 5 minus 2. This whole will be 5/5. So you simply do 5 minus 3, which will give you 2. The denominator stays the same. This whole will be 5/5. So you simply do 5 minus 4 for the numerator, which will be 1/5. Here you have 7/10. So this whole has to be 10/10. So you simply do 10 minus 7 for the numerator. This one, let me do a bit of writing. This one is 11th. So it means the whole has to take 11 parts. Now a whole will be 11 out of 11. So it's like saying 11 minus 9 equal to 2/11. So for this one, these ones, let me just write what we did. So they all take 5/5. Why? Because the denominator of the fraction we're trying to subtract from them is 5 parts. The denominator tells you the number of parts you're working with. This will be 5/5. This will be 5/5. This should be 10/10. This should be 20/20, right? So we're trying to find out, it's just been written the other way around. So this is 20/20. Why? Because the denominator is telling us the number of parts we're working with. This should be 8/8. So the denominator tells us that the whole has to be 8/8. And these are the answers. Pause the video and answer question 5 in 3 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. Remember what we said. The denominator tells us the number of parts we're working with. In this case, we do not really need to do what we did in the previous question that we answered. because we can just write our answers as mixed numbers. But if we're required to write our answers as top-heavy fractions or improper fractions, we can do what we did before, or we can use our answer and then convert it into an improper fraction. So by doing the denominator times the whole number plus the numerator. But we're not doing that now. So these are really straightforward. We simply just write the whole number and the fraction beside it. Next, we'll ask, is the statement true or false? You'll ask 3 plus 5, 4. 5 over 4 is equal to 4 1/4. Well, what you should know is that, remember that the denominator tells you the number of parts you're dealing with. Now, we want to write this as a mixed number. We want to check whether it is 4 1/4. We know we already have 3 wholes. So if we convert 5 over 4 into a mixed number, you can see 5 divided by 4, you will have one lot of 4 from 5, and you have a remainder of 1, which is 1 1/4. So rewriting this looks like 3 whole plus 1 1/4. Or you can break it down even further. This means 3 plus 1 plus 1/4. So you can see why it is 4 1/4. Let's do some new learning for the second segment of our lesson. What are the missing numbers so that the calculation matches the bar model? So this is our first example for the second segment of our learning. Well, if you think about it, we have a whole already shaded, and we have 9 parts. Now, thinking about it, the number of parts in which the whole or the bar model is split into tells you what should be written in the denominator. So we know already what should be written in the denominator. So this bar model here that has all of the parts shaded is the whole. And then we can see that we have 7 parts shaded. So we can confidently say that this is 7 over 9. But have a think, what should this part be? Well, 2 whole will mean having both bars shaded, all of them shaded. But if you think about it, what do we have to subtract so that it looks exactly like it was before? It would be these parts that have not shaded. Now, if you consider these parts that are not shaded, it means this will be 2 9ths, which will be that. So we know it is 2 9ths. What about this one? Have a think. What value do you think the 4 whole will take for the numerator? Already we know that we must have the same denominator, which is 4. But what number will be in the numerator if we have to write 4 wholes where we have 4 in the denominator? What value would the numerator take? Have a think. Well, if we start by saying 4 wholes, because that's what it means, we can simply say that 4 wholes, if we split it into 4 equal parts, we can quickly see that we have 16. So we can write this as 4 wholes subtract 3/4 is 16 over 4 subtract 3/4. Now, you could have done this a long time ago without even drawing a bar model, because by now you should know what we have said and said again and again. The denominator of the fraction you're trying to work with another whole number or integer determines the number of parts you're working with. So we know already that the denominator, if we rewrite these 4 wholes, must have 4 in the denominator. So very quickly, a way to do it is to just say 4 times 4, which is 16. But you have to write 16 parts out of 4, telling you that you have split you have the whole 4 wholes split into 16 equal parts, of which each part of the whole is equal to 4. Each of the whole is split into 4 equal parts. And then, of course, if you subtract 3 parts from one of those parts, from one of those wholes, you'll have your answer as 13 over 4, or 3 wholes, 1 quarter. You can also think about it in a different way. We do not really need to subtract anything from these other wholes, so we don't even need to divide these wholes into 4 equal parts. We only have 3 quarters to subtract, so it means we can split only one of those parts into 4 equal parts. Now, if we take away 3, we can represent the calculation like this, meaning the 3 wholes is untouched, so we'll write 3 plus whatever we have left after subtracting 3 quarters from a whole. Now that becomes 3 plus a quarter, which is 3 1/4. It's now time for you to practice what you've learned. Pause the video and practice question 6 in 3 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. So here you were asked to write an addition and a subtraction for the models. Here, this simply means a whole. You can see all the parts are shaded. All the parts are shaded. And then you have 2/3. And then if you were to consider it, if you had all these parts shaded, that will be 2, which is these 2 wholes. And then the part that is not shaded will signify 1/3. Here, you can see we have 6 parts. So that will be 2 plus 1/6. And then you may be thinking, why do we have 3 whole? Imagine we shaded all the 3 of these, that would signify these 3 wholes. And then subtract 5, 6, the parts that are not shaded, will give us the original. So that's how the calculations remain the same. Here we have a number line. Now, the number line is asking us to determine how to represent this calculation. Well, we have 11. You can see between 11, 10, and 11, we have 4 intervals. 1, 2, 3, 4. Now, it means that each of these is a quarter. Because remember how we work out interval values? We do the value between the numbers at the end of the number line of the interval we're working with, and we divide by the number of intervals. So 11 minus 10 is 1. 1 divided by 4 is a quarter. So we know it is increasing by a quarter every time. Now, if it's increasing by a quarter every time, each of the interval is equivalent to a quarter. It means that this should be 11 and a quarter. So this position here on the number line represents 11 plus 1/4. That must be equivalent to 12. Imagine making a jump going back to that position. You would have jumped through 1, 2, okay, a quarter, 2/4, and 3/4. Pause the video and answer question 7 in 3 minutes. Assuming you've paused the video and you've answered question 7, here are the answers. Let's discuss them. Here, Dora and Rosie are trying to work out 9 minus 4/11. What mistakes have they made? Of course, you can see that Dora has calculated 9/11s minus 4/11s. Well, here you can see Rosie has subtracted the denominators. We do not do that. Now, how would you calculate 9 minus 4/11? Well, let's discuss this really quickly because it helps us understand the concept of fractions even much better. Remember what we said, that the denominator tells us the number of parts that we have to work with. So we know when we convert 9 wholes, it has to have 11 in the denominator. And to find out the value of these wholes, these 9 wholes, we simply do, remember what I showed you before, 11 times 9. So this is 99 over 11 minus 4/11. So that is what she did here. And then our answer will be 95 over 11. And of course, we can change this into a mixed number if we're required to do so. Pause the video and answer questions 8, 9, and 10 in 5 minutes. Assuming you've paused the video and you've answered questions 8, 9, and 10, let's discuss the answers. For question 8, you were asked to work out the subtractions. Remember what we said about what value the whole will take. Well, one quick way to do this is to think about what we modeled before. We want to subtract 2/5 from 3 wholes. Well, we do not really need to use the 3 wholes. We can just keep 2 wholes on the side, which is these 2 here. And we know that we're required to subtract 2/5 from just a whole. Now remember, that whole must be equivalent to 5/5. So 5 subtract 2 is 3. So that's why we have 2 whole and 3/5. We use the same idea here. We can leave the 7 wholes on the side because we can subtract 2/3 from 1, a whole, which is left from the 8. That makes our calculation much quicker and easier because we do not need to convert the whole 8s into the top-heavy fraction and then do our subtraction and then convert back into a mixed number. A quicker way is to show the method we're using here. So that will be, because we have a whole left that we haven't used, that this whole has to be worth 3/3. Why? Because we have 3 in the denominator of this fraction that we're trying to work with the whole, the integer. Now 3 minus 2, just working with the numerator, will be 1/3. So our answer is 7/1/3. We'll use the same approach here. We can keep 9 on the side, but it has to be plus 1 minus 3/4. Now that is the same thing as 9 plus the whole has to be 4/4 minus 3/4. Now 4 minus 3 is 1/4, so your answer will be 9 1/4. We use the same approach here. Here we have 6 that we can leave on the side, but it has to be plus the whole, which is left from the 6, minus 10 over 19. Now we can have 6 plus the whole has to be 19 over 19. Why? The denominator tells us the number of parts wholes should become. Now we have 19 minus 10, which is 9 over 19. And that's why you have 6, 9 over 19. Really quickly for question 9, there are 6 episodes in a series. Brett has watched 3/4 of the first episode. Exactly how many episodes does he need to watch to finish the series? Now remember, she has 6 episodes. We're only talking about 1 episode here. So it means if she had just watched 3/4, we can simply say, well, 1 lot of that episode that she's watching, remember we still have 5 episodes left, will be 1 minus 3/4. Of course, remember this whole will take 4 parts because this denominator here is 4. So that's 4 over 4 minus 3/4. So it means we have 5 episodes and a quarter left because 4 minus 3 is 1. Here, Kim orders 3 pizza. So question 10, each pizza is sliced into 8 slices. Kim has 3 slices and Tom has 4. Exactly how much pizza is left? Well, if you think about it, if Kim has 3 slices and Tom has 4 slices, it means that they have had 7 parts out of the 8 slices. Now remember that they bought 3 pizzas. Now they have only used 1 pizza. So it means they have 2 left. But remember, from that whole pizza, there is one part left. So it's a bit like saying the two that they have left, plus 1/8. That's why we have 2/1/8. And that brings us to the end of our lesson. So far in this lesson, you have learned how to add and subtract fractions from integers. Integers mean whole numbers. It's a very important concept because it begins to help you to really understand what happens when you're dealing with fractions. Having fractions with the same denominators help you to understand that you're working with a common denominator. Hence, you can really know what you're adding or subtracting from the integers. Until next time, well done for taking your learning really seriously. Take care of yourself and bye-bye.